So you have a way to identify if velocity is constant. Anytime you have a straight line on a position time graph, velocity is constant. Whether it's a negative slope, or a positive slope, or a horizontal line. You've got a constant velocity. All right? One of the things you're going to get to do now, we're going to take a look at, is how do we switch between position time graph, which we learned how to make, and something called a velocity time graph. All right, well, on the left-hand side, we've got a position time graph. What's one piece of information we can tell from the line on the graph? Mackenzie, going up into the air? Oh, it's going forward. So if I have a positive slope, the object's moving forward away from the origin. Perfect. So another piece of information catching I can get from this graph.
Well, the starting position's at 2.
At?
2?
Yeah, the starting position's at 2 meters. Here's my origin, here's my reference. But it starts here. So it starts at 2 meters. That's the second piece of information it gives us. So we know it's moving away from the origin. We know it's starting at 2 meters. What else, Caitlin? That would mean my slope would be what kind of slope?
Is that like a curve or something? Like how would...
If I had a negative velocity, what would my slope look like on the graph? Great, so if I have a negative velocity, what will my slope look like? There you go. The negative velocity is you're moving towards the origin, or in the opposite direction of whatever you decided is forward.
Oh, okay.
Okay? Doesn't have anything to do with changing speed yet. That's the next unit.
Okay.
Ryan,
It has
question?
a constant velocity.
It has a constant velocity, exactly. How do you know that?
Straight.
Right, so we've got 3 things now. We know that it's moving forward away from the object because it's a positive slope. We know it's starting at 2 meters because we see where its initial position is. And we know it's moving at a constant velocity. One more piece of information, a quantitative piece of information I can get from this graph.
Like amount?
Yeah, absolutely, the amount. How can I find out the amount or the value of the slope? What do I need to do? Can I find the slope value? How? How do I find the slope of this line?
By doing the slope equation.
Yeah. Is that thing still running?
Yeah.
So, definition of slope. Help me out. Stephanie. How do I find the slope of a line? Okay, rise over run. So what about the rise and the run? Okay, so the change in rise. I start at 2. Where does it stop up here?
10.
10. So what's my change in position, my rise? 8. Okay, and my run is going to be change in time. What is that?
0 to 10.
0 to 10.
Or 10.
So final minus initial is going to be 10 minus 0. That's 10, right? So what's my slope? Okay, put it in decimals for me. 0.8, because it's 8 divided by 10, so I have 0.8. And my slope is meters over seconds. So there's my velocity, 0.8 meters per second. All right? Now, if I want to take a position time graph and turn it into a velocity time graph,